Hello everyone. In this session we are going to discuss about call and subroutine. So what is a subroutine is? A subroutine is a set of instructions which are a part of main code but written outside the main code. What does it mean? So it is a set of instructions which are required to be executed but they are kept outside the main code. Why it is kept outside the main code? We shall see. Whenever you want to do some repetitive operations, then what you have to do is you have to write that repetitive instructions for many times. When you do this, the length of the code also increases, and also the complexity of programming also increases. In order to avoid that, we are going for subroutine. And how to access this subroutine is we can access this subroutine using call instructions. When you execute call instructions, you will be able to access this subroutine. So as we discussed, what is the need to reduce the complexity of programming and to reduce the code length. So here is an example of one program that is written without subroutine. So what is this program is doing? This program is to generate a square wave on pin P2.3. So how you will generate this waveform is, it is nothing but it is high and low. It's a combination of high and low. High means 5 volts, low means 0 volt. You are changing the values at the pin P2.3 as 0 and 1. But whenever you are changing it from 1 to 0 or 0 to 1, you are giving some delay. Why we require a delay is, you can see in the waveform that the waveform has some finite duration of on period and finite duration of off period. So we shall come to our code now. So the first line is org means origin. It is an assembler directive where it says that where your code starts from. So the main code starts from origin is 0100H. So now the first instruction is clear P2.3. That means you are making the pin as output port. Next, once you make the pin P2.3 as output port, the first you can see that you are having high voltage. So that is on period. In order to get this on P2.3, what you have to do is you have to set that particular pin by using instruction set bit P2.3. And next come to the low. So when you want to have a low in that, what will happen is you have to clear it. To get low voltage, you have to use instruction clear. But before doing that, you can see that there is some finite duration of this high voltage. There is some finite duration of this time period. This is finite in duration. Now you have to give some delay. Give some delay means you have to retain that high for some duration. How to do that is you have to use a delay function. So how to design a delay function or a delay instructions is by using counters. The simple thing is by using R2 as a counter, and you are making it to count until it becomes 0. When you do this, you are spending the processor time in counting operations and you are doing nothing. The processor is involved only with this operation. Until then, there will be no change in the pin P2.3. The P2.3 remains high until these two instructions get completed. Once these two instructions are completed, so now you are going to change the status to low. So by making use of instruction clear P2.3, again we can see that this low is of some finite duration. In order to get this time period, what you have to do is, again you have to have some delay. Having a delay means retaining that 0 for some finite duration. How much it is, that depends on the count value that you have taken into R2. So the processor is involved with just counting operation and it does nothing. Meanwhile, the status of the pin remains as it is without change. Next, again this process repeats. So now you got first high and first low. This is first high and this is first low. Now you got only one high and one low. Now you should have the further waveforms. So next again this process repeats, making it as high, giving some delay and again clearing it. Again giving some delay, again making it as high, again clearing it. So now you do this for how many times? 6 times. So because you want 3 on period and 3 off period. This is done without using subroutine. So if you make a notice here, this move R2 comma hash 0 FF and here DJ NZ R2 comma here is written very repetitively. So that means you can keep this 2 instructions outside the main code and you can call them as a delay and you can just call it whenever you want an access to it. So here is the concept of subroutine. What you are doing is, here is the main code and the main code is a set of instructions, and whenever a call instruction is encountered, what you will do is the program control is transferred to subroutine and you are executing the instructions in the subroutine, and once a return instruction is encountered in the subroutine, it goes back to the main code. It is mandatory to write return instruction RET. If you don't write this, the program controller or the program flow will be kept into infinite loop. So that means it will not be able to come to, it permanently remains in the subroutine and it will never come to the main code. So here is code for subroutine. The first is output you have set. So first you have to get high. So how do you get an high here? See here, you got an high and after a delay you're going to get your low. So this is what is your delays. First you made the pin as high, you retained it for some delay and you are making it as 0 here. This is 0 and this is 1. This 1 is retained for this much amount of time and it is made 0 after this delay, and this delay will be proportional to the value that you have loaded into R2. Next, this 0 has to be retained for certain duration. 0 has to be retained for certain duration. For that, what you have to do is, you have to call a delay function. So in this time, you are going to retain this 0 value. Is that right? And next what you will do is, you are using an instruction called as setBit P2.3. When you use this setBit P2.3, you are going to get an high here. Next again this is maintained for certain duration. So that is your delay. And again you are making it as low using your clear P2.3. Again you are giving some delay to have this low for certain duration, and again you are making it as high. So this process is completed until you are able to get all the highs and lows. So here you are using a delay function which is move r2 comma hash 0 ff djnz r2 comma here as a separate program in delay. Next, RET is written. It is mandatory to write the return instruction to go back to the main code. Next, here we shall take an animation of a small animation of how this instructions do work. Okay. So here is the main code. So the PC is holding an address of the next instruction 0102. Okay. Now it will what about the stack? The stack pointer is pointing to 07, that is the default address of the stack pointer whenever you start the system is 07, right? Next what happens is it will come to the execution of next instruction. When it comes to the execution of next instruction, there is a call to the subroutine. That means it has to transfer the control to subroutine. So whenever that you are going to transfer this control, it is necessary to have a written address. So when you should come back and where you should come back. So that is what is done. So that means uh, the PC now is having an address of 0104. This is nothing but the written address. Again, where you come back and you are going to resume your execution of main code. So now this is saved into the stack. The stack pointer gets incremented by 2. The default was 7, now it is 9, and the return address is stored in the stack. Now the control is transferred to the subroutine. So now you can see that you are executing subroutine, and the PC content has to be the address of the next instruction 0108. So next what happens is it is going to execute an instruction of 0108 at an address of 0108. At that time the PC value will be 1100. So now what happens is 0110 contains a written instruction. So written instruction means it says the control to go back to the main code. So where it will go? It will go to the written address which is stored in the stack pointer. What is there in the stack pointer? You can see that what is there in the stack pointer, it is 0104. That is nothing but it is your SJMP instruction. So now what happens is when this return instruction is executed, the PC is loaded with the return address of 0104. You can see that it is loaded with 0104. Now the stack pointer gets decremented, and now the program flow will change to the main code. It will go to the main code now. It will go to the main code. So once it goes to the main code, you can see that stack pointer is decremented, and it is pointing to the initial 07. It is decremented by 2. Now we shall see the types of call. So based on the range of call or subroutine, you are going to classify it as A call and L call. A call means it is absolute call. It will be within the range of 2 kilobytes. So you can see that this will be of 2 kilobytes. This will be of 2 kilobytes. Whatever you are saying here, this is of 2K. And this entire thing is of 64K. So now, based on where is your subroutine, you are calling it as A call and L call. If the subroutine is within this 2k range, then it is called as A call. And if you are going to have a subroutine anywhere in the 64k range, then it is called as L call. And next we shall see what is the difference. A call, the subroutine will be within 2 kilobyte range, whereas in case of L call it can be anywhere in the 64k range. And A call uses 11-bit address and L call uses 16-bit. Why the address is more means it has to cover the entire range. And next, A call uses 2-byte instruction, is a 2-byte instruction, and L call is the 3-byte instruction. So this is about your working of subroutine and call functions. Thank you.